This is the first part of the relay pumping. I call this engine the supply engine because it's supplying water. It's at the hydrant. The main idea of relay pumping is that you're going to put an engine at the hydrant and you're going to push every ounce of water that you can to the fire. Okay? And you may need multiple engines in between you and the final destination, which is the fire attack engine. In this scenario, you'll only have two engines. One will be the supply and the other one will be the fire attack. Talk about the different types of engine operations. You have relay pumping, which is taking water and pushing it a great distance to the fire attack. You have tandem pumping, which is you need more pressure. So you have another engine bump up the pressure to give the other engine the pressure that it needs. Dual pumping, which is intake to intake. You're sharing water from the same hydrant. Tank transfer is what we do on fire ground all the time. Basically, you're giving your tank to the fire attack. So you hook up your discharge to their intake. You're giving all your water, 500 gallons. And those are the different kinds of operations. Right here, we're going to be doing the relay pumping. And I'm at the hydrant. And this is a great opportunity, as you saw in the videos about the maximizing the hydrant. When you sit to a hydrant, if you take the time and the effort to drive to a hydrant and you want to get all the water you can out of that thing, go ahead and do maximizing the hydrant. Whichever method you use, the ram's horn or the koozie. Both are great methods, but go ahead and set it up. Once you start flowing water to the fire attack, you're not going to shut down and redo it, okay? So set it up when you first get here. Here I am, I'm set up to the hydrant. I know I've got water. And I'm not going to do anything until I know that they're ready. So I'm going to be communicating with that fire attack. Hey, are you ready? It could be over the radio, a runner, whatever. Whatever is the most appropriate method. If I can see him, I can walk to him, then great, I'll do that too. But you remember, communication, communication. I don't want to charge that 5-inch line and it be uncoupled and starting to hit people. It's very dangerous. So whenever they let me know that I'm ready, I would go ahead and open my discharge. I know I have hydrant. I know that because I see on my intake gauge that I have water. I know that I'm hooked up to the 5-inch discharge, and that's the one I'm going to open up. And of course, I'm going to watch my 5-inch discharge gauge, okay? Always. Now, as I start to flow big water, one of my concerns is my intake, okay? Right now, I'm not flowing any water, so this is my static pressure. But once I start to flow water, that's going to be my residual, whatever's left over. I don't want to go below 20 psi, okay? That's a backup. You can go all the way to zero, but if you're at zero and something happens within the system and it causes you to suck your hose down and cavitate your pump, well, you didn't have any leeway. That's why we have that 20 psi. It gives us a nice buffer, okay? All right, so I'm going to open up my 5-inch discharge. I've talked to them. They're ready for water. Okay, I'll open it up. I'm throwing water at my 5-inch discharge. Look at my intake. It didn't drop very much. Now, in relay pumping, a good standard in AFD is that we start, when we relay pump, at 100 psi. That's going to push a lot of water through that 5-inch hose. Okay? Think about it. What was the friction loss of 5-inch hose? It was like 0.08. Okay? Nothing. Very little friction loss of 5-inch hose. So if I'm pumping 100 psi through it, we're getting a lot of water. So I bump it up, watching my 5-inch discharge and my intake. Because remember, I'm flowing a lot of water. I don't want to suck this down. So using the throttle, pump up to 100 psi. Okay. My residual is about 50, a little above 50. Now, look at this. This is a good example. There's my master discharge. Right? That's my pump discharge pressure. Look at it. It's about 135. Now look at this on my 5-inch gauge. It's 100. So we have about a 35 psi loss in our pipe from our pump to our discharge. That's a lot of pressure loss. Now, there we are. We're flowing water, and if that's all we do right here, then great. we're good. But if they start flowing more water, and say this drops, right? They start to flow water, and let's say that my pressure dropped to 80. Well, what you do is you try to keep this at 100 psi. If it goes above 100, you drop it down. If it goes below, you bring it back up. As long as you've got 20 residual. Those are your limiting factors. Try to keep this at 100 as long as you're above 20. So, they open something up, it dropped down to whatever, about 80 or so, I'm going to adjust it back. Got 100. Watching this gauge and watching this gauge. Now, say they shut everything down and it went up. What am I going to do? Again, I'm going to adjust my pressure with my throttle and bring it back down. And really, that's my job, is to watch this gauge, try to keep it at 100, and watch this gauge, try to keep it at 20. If I'm sitting here and all of a sudden this gets to 20 psi, I'm done. And I need to get on the radio, and I need to tell somebody. The radio transmissions in this operation is once I'm on hydrant, I let somebody know. Once I'm sending water, hey, are you ready? They say, yeah, okay, I'll let them know I'm sending water. Once I reach 20 residual, I let them know. It's important everybody understands what's going on the fire ground, what our water supply is doing. Now, shutting down the operation. This is one of the most important things you can do. You, as a supply engine, we're here at the hydrant. We've got all the water, and we're sending it over there to the fire attack. If I shut this down, and I killed this valve, I shut it closed, what's going on at the fire ground? They've got that pump, and they think they got all this water, and all of a sudden they don't have any water. And now their pump is spinning real fast, and it's crazy. They don't have any, they burn up their pump, and they cavitate it, whatever. So, you don't shut down until you know the fire attack engine shut down. So what'll happen is that fire attack engine, they'll call you, and they'll say, hey, we're shutting down the operation. And you'll be able to watch it on your gauge. Right? You'll be able to see it. And as they shut it down, you, again, just adjust it. Keep it at 100. As they shut down, you keep on adjusting. They shut down a little bit more, you adjust. And then pretty soon, whenever they're done, and they're totally shut down, they'll call you on the radio, they'll say, our operations are shut down, you can shut down at the hydrant. And if that's the moment, that's the time that it's okay to go ahead, throttle down, close your intake or your discharge valve to shut down the operation. That's it for the first stage of the supply engine and relay operations. This is the relay operations, the fire attack engine. This engine is at the fire. The supply engine is over there at the hydrant sending me water. And this hose right here is coming from that engine. They're hooked up to the hydrant, hopefully maximizing it. They're sending me water through the 5-inch hose into my intake. They're pumping about 100 psi. Right? And so this is what I've got in my intake gauge here. Now I'm going to flow water. I know I've got water. I've communicated. Remember, a lot of the relay pumping operations is communication. Whenever you're ready, you need to let that engine know, hey, I'm ready for water. And then they'll send you water. Same thing when you're shutting down. Hey, we're going to shut down this operation, and then you shut down first, and then let them know when you're shut down. So now that I got water, I'd open my discharges, okay? I've got a ground monitor on the ground. I'm opening my 5-inch discharge, pump 100 to it. Watching my discharge and my intake. Same thing holds, always. You're always limited by what's coming into your pump. If you don't have any water, you don't have any water. So every time I do something, I watch my gauge here and I watch my intake gauge. All right, so now I've got a bundle. They're pulling a bundle to attack that fire over there. That's going to be number 4. Okay? And what do we have here? We have a multiple handline situation. I want number 4 to be 125, and I want this one to be 100. So I'm going to gate down number 5 as I bump up my pressure. So I bump up my pressure a little bit. Watching these gauges and my intake gauge. Number 5 has gone up to about 110 or so I'm going to back it off a little bit. Okay. Back down a little bit. Now, if you look, is that okay? Yeah, that's fine. Look how that needle's bumping up and down. Can I really tell what I'm pumping there? And I have a general idea, 100, 110 or so. One thing to remember, and it's a good habit, no matter what you're doing, whatever discharge you're flowing, but especially with big water. Once you set that valve, lock it. So I would turn this and lock it in place. Now, it can't shut down and it can't close on me. Okay? Again, here I am, the FireTac engine. The supply engine's sending me their water. I've got about 50 residual left. I'm flowing a ground monitor and a bundle, so I probably can flow something else. So I'm going to flow the number 1 discharge. I'm going to flow number 2. Okay, again, the reason I'm doing this is I want you to see. Whenever I do something, something does happen. I open up the number 2 discharge. My number 4 discharge dropped a little bit. And so did my 5-inch. Also, look at my master intake. It dropped a little bit because I'm flowing more water now. So, I want to set this one at 125 too. Okay? So, here's the key. I bump these two up at the same time. I want to lower my 5-inch discharge to 100 because that's where I want it. Lock it. That's a 125. My 4-inch is a little above that. That's probably okay, but I'm going to knock it down a little bit. There we go. And lock it. So there I am. I've set my pressures on my gauges. I'm set. Now let's look at your intake gauge. I'm about 30 psi. I'm flowing a lot of water, okay? I've got a little bit more to give, but not much. Now here's the moment. The chief comes up and he says, Josh, the fire's out. You can go ahead and shut down. We don't want that engine. Look how much water I'm flowing. I'm flowing a lot of water out of this engine. If that engine at the hydrant shuts down, my pump is going to go crazy. It's going to burn up, it'll spin. I've got no water. So I've got to shut down gradually first, okay? So I'm using my throttle, nice and easy. Okay? Shut down my discharges. Close them. Remember, every time you do a valve, try to be nice and slow and controlled. And again, notice how I lock these. I'm flowing a lot of water, so I need to lock these valves. Okay? One of the things we haven't talked about before, but it's always a good habit. Whenever you have the opportunity to fill your tank up, okay? I want to do that before I shut the hydrant down, don't I? Because once I do that, I'm not hooked up to a water source. So once I'm full, I shut my intake, and then I let the engine at the hydrant know we'll shut down at the FireTac. You can go ahead and shut down your operation. That's very important. I can't say that enough. And that's it. That's pretty much it in a nutshell. One thing I didn't show you because we don't have it on this engine. But this is actually right here, if you look, my hand, this is a intake discharge, intake pressure relief. On most engines, you guys know what it looks like. It has that X in the middle. What you would do is you would set that at 100 psi, okay? So once you get your water in from the supply engine, it's coming in like this, and say it's 100. Well, you take that and you would set it at 100. And that way, whatever pressure comes, say 200 psi is coming at you, it's not going to go into your pump. It'll dump right here, okay? So in relay operations, it's really important that you do that. Let's say that there is the supply engine and then 3 other engines. Well, the supply engine is discharging, right? So they don't need it set at 100. Maybe they'll set it at what the hydrant's at, maybe. But then each engine in the loop, each engine in the chain needs to set their intake at about 100 psi. And that way, anytime there's extra pressure that comes into that system, that engine will take care of it and then send on what they're pumping, 100 psi. And then when it gets to the next engine, that engine will take care of any excess pressure, and so on. And that's it in a nutshell, relay operations.